Hey guys, in this video I'm going to teach you about Newton's method, or how to approximate roots and solutions. As a reminder, you want to pause and try the examples when you're prompted, and there are always free guided notes available at divideandconquermath.com. And hey, if you could do me a solid, maybe consider giving this video a like or subscribing to my channel or leaving me a comment. Just love getting some support for free math on the internet. So let me begin by showing you just the idea behind this visually. So let's say I have this function f of x. It totally doesn't matter what the function is. And what I'm trying to do is figure out what is the root. So i.e., where does this function cross the x-axis? And let's also say I have no good way to actually figure this out. This is kind of the idea behind Newton's method. What do you do for this if you have no idea how to actually figure out what this is and you know this is some crazy decimal? So what you can do is you can actually use tangent lines to do this. So I'm going to start by making a guess. This is how Newton's method starts. And I'm going to make a terrible guess. I'm going to say, I think that this is where the root is. So I just make a total shot in the dark here and I say, here's my guess. Now I have to know the x coordinate of this. This would be, and we're going to call this x sub 0 or x sub naught. And now what I'm going to do is from this point, I'm going to create the tangent line, and what I'm specifically interested in is where this tangent line crosses the x-axis. So if you visualize this, so here's my tangent line, and you can see that where my tangent line went through, it's like nowhere near where the actual root is, right? But what I'm most interested in here is what is this point here? So this point here, this will get me to a new x-coordinate. So we are interested in the x-coordinate here. So what I do from this tangent line is I figure out what is this x-coordinate that crossed the x-axis. This is going to be our new guess. So here's where my graph actually crossed the x-axis, and so I'll try to mark this really bright. So now you can see this. So what I want to basically do now is make this my new guess. So here's where my new guess will actually fall on this graph. And now I'm going to call this next guess x sub 1. So now I'm going to do this again. So I'm going to draw the tangent line that goes through this, and I'm specifically interested in where it crosses on the x-axis. And now you can see within two guesses, look at how much closer I am to where this tangent line crosses the x-axis, how much closer it is to the actual root. So this, if you can see this now, this little point here, this is actually going to be now my next guess. So I'm going to come up here on my graph and I'm going to draw the next tangent line, and it's almost impossible now to kind of see all of this, but you can kind of visualize here that I've actually crossed where this root is. So the idea behind this, and this would be x sub 2. Okay. So this is kind of the idea. You're using these tangent lines. You're interested in where the tangent line crosses the x-axis, and then you use that as the new guess, and then you kind of keep going with this. So what I want to do is I want to think about how do we actually figure this out? What's the method behind this? So the motivating question here, which maybe you want to pause the video just to think about this, you should be able to explain this just in very plain terms. How do you find the equation of a tangent line? If you want to pause the video and just write down some notes, go for it. Hit play when you're ready. Okay, so to find the equation of a tangent line, first of all, you need to know your f of x, your f prime of x, and you need some point from f of x. These are, for Newton's method anyways, these are the ideal things that you need to know. Technically, if you wanted to make a tangent line, you don't even need to know what f of x is, but for our purposes, these are the things that we need to know for this. So I've kind of modified this tangent line. Maybe I'll just write this for Newton's method. Okay, so you need this information, and then after you have this information, so what you can do is you can use the point slope form kind of with this information. So what I want to do is now I want to rewrite this point slope form, but I want to use this with this notation. So if this is my point slope form and I already know I have some point, so I really want to kind of change this now so that now this fits more of what this situation was over here. So first of all, let's start this with x sub 0. Let's use our guess in this. So I'm going to be specifically using the point x sub 0. So this is starting with the general point slope form, but I'm going to use the x sub 0 and I'm going to put that in place of the x sub 1. Then the other things that I want to do here, I want to think about what would my m be in this case, because we're trying to, again, write this in kind of the Newton's method way. So for m, what I have to do is I have to find what f prime is, and then I would plug in that x sub naught. And then for my y sub 1, well, that's going to be just what the result of plugging in x sub naught is into this function. So I'm going to make these replacements into this. Trust me, this is going somewhere, so let me do that. Okay, so what I've done is I've taken now my point slope form and I just kind of translated it now into what I need for this situation here. Okay, so now I want to go one step farther with this. We said that in our Newton's method, we are specifically interested in where the tangent line crosses the x-axis. So this is the general setup to find the tangent line, but now I want to reform this, or I want to modify this so that it actually reflects crossing the x-axis. So if you look here, and if we just think about this x naught here, so I can't really say anything about the x coordinate of this piece here, and maybe just to be nice and clear, I am talking about this point here. So I don't know what the x coordinate is here, but I do know something about the y coordinate. What can you definitely say about the y coordinate here? Well, y is definitely 0. That's what it means to cross the x-axis. If you cross the x-axis, that means that your y has to equal 0. So now what I want to do in this situation is I want to replace y with 0. So this is what will reflect that I've crossed over the x-axis. So now let me update this one more time. Okay, so now here's where I'm at. And what I'm trying to do is I'm trying to figure out what is the x coordinate of this. Well, I just plugged in something for y. This f of x naught, f prime of x naught, and x naught, these are all representing some number, right? So the only thing that's actually left that I could solve for is this x. So now what I want to do is I want to solve this for x, and what that will end up doing is that will help me figure out what is this actual point here. This is the most general way that we can do this. So now I want to solve for x. So first things first, in looking at this, I can divide both sides by f prime of x. So I get negative f of x naught divided by f prime of x naught, and this equals x minus x naught. And then I can add x naught to each side, so I get x equals x naught minus f of x naught over f prime of x naught. So here's actually the idea then of how do you figure out what this little point here was. This is actually the math that goes into it, and it's all just based off of derivatives and the point slope form and basic algebra. So it's a pretty simple idea actually. So this actually gives us then the formula that we need. It's an iterative formula that we use for Newton's method. So I'll show you what that is now. This is the formula that you want to have written down and that you need to use for Newton's method. So notice that in this formula, I've actually written it just slightly different. I have x sub n's here instead of x sub naughts, and then this says x sub n plus 1. So this is talking about how do you get to the next x? Well, you use the previous guesses to figure this all out. So now what I want to do is I want to just show you two examples of kind of different ways that you can use this, just to make you more comfortable with it. So here's a classic question. Use Newton's method to approximate a root for f of x. Stop when the first 5 decimals do not change over 2 iterations. So I've got a function. Sometimes you are given an x sub naught and sometimes you are not. And also just FYI, so different books do different things. I'm going to do this so that I can just show you what it looks like when these answers stabilize. But other ways that you could be asked to do this, you could just be asked to like find x sub 2 or something. So you'll kind of understand all this once we get going with this. Okay, so here's my function, here's my x naught. So remembering my formula here, maybe I should just show you one more time. So here's my formula. So I need to know obviously what f prime is before I even get started with this. So just to show you, how do I get to x1? So to get to x1, I have to use x sub naught minus f of x naught over f prime of x naught. So here's how you would get to the first one. So you do this whole calculation. So now what I've got to do is I've got to figure out obviously what is f prime of x. Well, that's nice and simple to figure out. So we've got 3x squared plus 2x. So basically now what I've got to do is I've got to plug in this number here into this and into this function. So now I'll show you what this actually looks like. So for my x sub 1, this will be negative 1.5 minus f of negative 1.5 over f prime of negative 1.5. And maybe just to be slightly more explicit about what this means, so I'll just write out now what does this actually mean. So let me just erase this. I got to save a little space here. And I'm going to plug that in just so you can really see it. Okay, so now you can see that I have actually gone through and plugged negative 1.5 into the function over negative 1.5 into the derivative. So now what you have to do is you just have to work all of this out. And when I worked this out, I got negative 1.46667. So we're supposed to take this out to 5 decimal spots in this particular problem, so this is what I want to do. So this now is my new x1, and now we're going to repeat the process. So to get to x sub 2, so just to be clear about this, I'm going to use the guess from x1, and then I'm going to subtract off f of x sub 1 over f prime of x sub 1. So now, wherever I see an x sub 1, I'm going to replace it with this negative 1.46667. So just again to save some space here, let me just erase all this and plug all that in. Okay, so there's what everything looks like plugged in. So you can see this getting kind of big. And so you might want to just figure this out on your own. Pause if you need to. I'll tell you what I got. So when I worked all this out, I got negative 1.46557. So this is my x sub 2. Okay, so now I'm kind of running out of room here. So hopefully you've kind of written all of this down. Pause if you need to write anything down. I'm going to clear some space, because obviously I've gone from 64557 from 6667, so I have not stabilized yet in my decimal spots. So let me clear some space and we're going to do it again. Okay, so that's what I got in the last iteration. So now I've got to continue on. So I'm hopefully you're kind of getting the idea behind this now. So now I'm going to take the previous guess, 1.46557, and then I'm going to plug that into the function and also into the derivative like shown. And so now, and this is f prime. Okay, so now I have to work all of this out. And again, if you want to pause the video just to figure this out on your own, go for it. I'll tell you what I got. So I got x sub 3 equals negative 1.46557. And now look, I'm out to 5 decimal spots. This was x sub 2, this is x sub 3, so this is what we're looking for. So a lot of times with this Newton's method, I know it's like a lot of stuff to kind of compute. It's just a lot of computation. But the nice thing is a lot of these problems are usually going to only have a couple iterations that you have to go through just so you kind of get the gist of it. So what this is saying then is that this should equal 0 if I were to plug this into this. And think about if you were to just trying to find a root of this or where this crosses the x-axis, it's not like you could just factor this. You're going to have to pull out all kinds of different methods to try to figure that out. So this is a nice way to just kind of approximate this. Okay, so now I just want to make sure you kind of understand, like, what does this even mean? So here's the question. How did we do? So here are the 3 real guesses that I came up with from this method. So first things first, so I want to plug negative 1.5 back into this function. So if I do that, so I got negative 0.0125. So this is definitely nowhere near 0, right? I would say this is kind of far off, so this would not be a good guess. So okay, so far so good. Okay, so now after we did that, here was the next guess that we came up with. So if I plug this into this function, what would I get? Okay, so now I'm getting a little bit closer to 0, right? But I'm still kind of a bit off, but you know, we're definitely moving in the right direction. So now here was the next one that I found. And so if I plug it back into my f of x, so what do I get now? So my calculator actually gave me something in scientific notation, which means this is going to have 5 zeros in front of it. So this is getting pretty darn small, right? So the way that I kind of think about this is really almost 0. So it's not perfect, but the idea here is that you get a pretty close approximation. And of course, if you really wanted to get very, very close, you would take this out to more and more decimals and you would wait for it to stabilize more. But we kind of get the gist of this. So that's kind of the idea behind this. Now I want to show you one other way that you can do this type of example. So use Newton's method to find a solution for this equation here on this interval. And we're going to do the same thing, so we just want to stop when we have five decimal places that don't change. So before I get too far in this, I just want you to notice how this is a very different question from what I asked before. So if we go back to what we were doing before, I gave you, here was the previous example, I gave you the function and I asked what is a root. So that was asking for where this crosses the x-axis. In this case now, I didn't give you a function. I've given you this equation and I'm asking you to solve it. And basically what you have to do is you have to force this into the format of the previous problem. And then I've also given us this interval, which, you know, it's kind of arbitrary, but it's just going to help us to like kind of start somewhere with a guessing point. Okay, so first things first, I need to change this into the language of find a root for this. So the equivalent problem here would be find a root for f of x equals, so I'm just going to take 4x minus sine of x minus 4. So think about what this is actually doing. I am basically taking my 4x minus sine x minus 4, which is the same thing as up here. I've just subtracted the 4 over. So now if I say find a root for this, I'm basically setting this equation now equal to 0. So tomato, tomato, right? So that's kind of the idea behind this. So that's why we're going to do this, and we're going to change it to this. And if you are given an interval, so some books give intervals, some don't, some tell you where to start. So I just want to make sure I'm totally clear with this. It totally doesn't matter what your first guess is. Just make a guess. So when I worked this problem out, I had no idea what would make this equal 0. I didn't even look at this on a graph. I just wanted to see what would happen if I made a legit guess. So my first guess is going to be 1.5, something between 1 and 2. Just totally arbitrarily chose that. So there's my first guess. So now what I want you to do is I want you to determine what is x sub 1. So pause the video here. Here's your f of x. Obviously, you're going to have to figure out what f prime of x is and then do the calculation for this. So pause the video and figure this all out just to make sure you've got it. Hit play when you're ready. Okay, so here's my x sub naught. So like I said, we've got to know what f prime of x is. So this will be 4 minus cosine of x. And so now what I've got to do is I've got to plug 1.5 kind of into this. So the way that this is going to look, this is going to be 1.5 minus f of 1.5 over f prime of 1.5. And so you're going to want to plug 1.5 into the top here, and you're going to want to plug 1.5 into this. And if you work all of this out, so I'm going to kind of omit plugging it in because I'm hoping you guys kind of got the idea with this. So this will be this decimal. Okay, so like I said, we want to have this stabilized to 5 decimal points. So now what I want you to do is I want you to get to x sub 2, continuing on the pattern, and see if you can actually finish this now till you get it to stabilize for 5 decimal points. Hit play when you're ready. Okay, so now I need to plug this in to the same formula. So this becomes 1.24486 minus f of 1.24486 over f prime of 1.24486. Okay, so if I plug all of this stuff in and I figure this out, I got 1.23613. And then, so obviously I haven't stabilized, right? So I'm still changing decimals. So now let's go to x sub 3. And so now I'm going to use 1.23613. So plug all of this in, 1.23613 over f prime of 1.23613. Okay, so now I have to plug all of this stuff in. And then what I get is 1.23613. So now I have my decimals have stabilized to 5 spots. So that's what I wanted. Okay, so once again, I just want to kind of show you how did we actually do. So once again, I'm going to plug my guesses now into this function. And this is just to see how close should we actually get to 0. So I'm going to plug it into this function here. So if I plug in 1.5, so what I got was 1.025. So this is like not close to 0 at all, right? So this was a pretty terrible guess, really. So now if I plug my next guess that I found, this 1.24486, if I plug that into this function, let's see, what do we get? So I get, okay, going the right direction, right? So at least this isn't a 1 here anymore. So this is definitely smaller, not 0, definitely not 0, but we're going in the right direction. So this is good news. And so then if I plug in this final guess, so once again, my calculator spit out scientific notation. So this is even closer to 0 than the last one that we did. So this is, again, almost 0. Once you get to this scientific notation, and maybe the number right here is pretty high, this is telling you you've got a bunch of decimal spots in front of here, so we're getting pretty darn close to 0. Again, if I wanted to make this even better, I would just take this out more decimal spots and just wait again until it's stabilized. So that's kind of the idea. So that covers Newton's method. So I'll leave you guys here, and thanks for watching. Hopefully I will see you guys in another video. Bye!